Hello, I am Meg, and I'm going to talk about the quarterly plan for remote paper prototyping testing, or what is now fondly known as mixed fidelity remote prototype testing. So the first thing I'm going to talk about is our project goals for this quarter and the motivation behind MFRPT. So Kevin made an awesome system, our PPT, that allows us to maintain the affordances of lo-fi prototyping in a mobile development environment. However, some app experiences using this platform are still impossible to prototype. So this gave us the opportunity to provide a mobile app platform that developers can use to allow them to quickly and efficiently prototype novel app experiences. So, in summary, our goal is to create this system and then also to explore more generally how mixed fidelity elements can make prototyping more efficient and more informative for designers. So, our goals for this quarter are a little hefty. We're going to try to create this system, answer the questions I just discussed, and also to write and submit a research paper. So if we're successful, we want to have a system that is ready out of the box to be used by designers. And then we also want to have conceptual answers to the question about how mixed fidelity elements can impact mobile designers and how we can improve prototyping in that manner. So in terms of design goals, the user problem that we're focusing on is, although that there is a system that allows us to prototype mobile apps quickly, certain experiences still cannot be prototyped using this method. So our design argument is that we want to be able to prototype critical app experiences and be able to obtain information on them early in the design process. And our timeline is that we want to finish our system and have the platform ready during Sprint 3. We want to test our system during Sprint 4. And we want to finish our paper in Sprints 4 and 5. And we want to test on real app designers. So we're going to look either to students in DTR, researchers in the Delta Lab, or find some local designers who work at design agencies who would be willing to utilize our platform. So if we want to make this system, we definitely have some hefty tech goals that we want to finish, specifically by the end of Sprint 3. So we want to have a full-fledged mixed fidelity prototyping system built on top of Kevin's project, RPPT, where a paper prototype is oriented under a camera and a stream of that prototype is visible on the user's iPhone. So a designer can orient a paper prototype underneath a camera, and the user can interact with that paper prototype via a stream on their iPhone. However, with our system, some elements that the designer is orienting on the paper prototype will be represented as paper on the designer's side, but are going to be streamed to the user's iPhone as digital elements. So for example, in the previous iteration of our platform, a red paper rectangle was streamed as a keyboard on the user's iPhone. So one of the big changes that we want to make this quarter is we want to identify these elements where we previously used color. So as I said, a red rectangle. We now want to identify these elements as QR codes. This also offers us the advantage of allowing us to differentiate between different types of data using QR encoding. So I gave the example of using of streaming a keyboard element, but another type of element that we experimented with last quarter was photos that the user had taken on their device. And this became difficult because if we wanted to identify photos with a blue rectangle, we couldn't differentiate between all the photos that the user had taken. However, taking advantage of QR encoding, we can now label each of these individual photos and allow them to be individually represented on the interface and overlaid in that manner. So that is one of the advantages of QR codes. Another advantage of QR codes is we were having inconsistencies with color and different lighting, and also inconsistencies in computer vision with color, even in standard lighting. So hopefully QR codes will offer us more consistent and a more reliable and more robust scheme for detecting different elements. In addition, sometimes our hands would, especially because in our specific system, the designer is orienting underneath the camera, and so sometimes our hands would, the computer would identify our hands as different colors and trigger different iOS elements. So that was an issue as well. So hopefully QR codes will take care of that issue. We also, this quarter, want to allow the overlay of physical objects on digital elements. So that's a little confusing as a sentence, but think Snapchat filters. So we want to, for example, overlay dog ears, which were potentially drawn using lo-fi methods, on top of digital elements. So a person's selfie camera that's being streamed on the interface. So this is a little bit technically challenging. We plan to do this by applying tracking.js's feature detection feature in order to create images of the paper objects. So the computer vision would, if a picture of dog ears is underneath the camera, they would use feature detection to extract those dog ears and create images of those dog ears. And then we will send those images to the iOS app. And the iOS app will overlay them on top of the digital element, the selfie camera, at the appropriate coordinates. And then, in addition, we plan to still have a stream of the glass and then live stream of the user's interface, which we'll do using OpenTop on the control center. And this will provide us both contextual data, or provide the designer with both contextual data, and then also will allow the designer to get feedback on the transition from lo-fi to mixed fidelity, so they can check with the control center to make sure that the QR code that they put down was being rendered as the appropriate element. So that's it with our tech. And then our research goals is, our research question is the same as it was last quarter. How can mixed fidelity, paper and digital methods make mobile paper prototyping more efficient and more informative for designers? And so as I kind of discussed, we think that mixed fidelity elements can definitely make it faster and more informative, specifically by allowing designers to quickly prototype app experiences that can't be prototyped using other methods. And we're going to confirm and reject this hypothesis by conducting a study using our system, and then using the study to determine if designers are getting better quality feedback with the mixed fidelity approach. Thank you so much, and we're looking forward to an awesome quarter.